TI-84 graphing calculator. Welcome back to old school math. Today we're going to jump back into the TI-84 graphing calculator and we're going to take a look at some advanced matrix operations. We're not going to go straight there though because we've got a few notes that we want to take first. Into this video you will be able to use a graphing calculator to perform operations with the identity matrix and find the determinant and the inverse of different matrices. Let's take a couple notes on the identity matrix. So the multiplicative identity, going back several years in math class, just says that any number multiplied by 1 is just that number, or A times 1 equals A. Matrices also have a multiplicative identity that's called the identity matrix. It's a square matrix with just zeros and ones. They look like this: 1 0 0 1, or something like this: 1 0 0 0 1 0 0 0 1. If we take a look at these two matrices, we notice that they have ones going across the diagonal and zeros everywhere else. If you multiply a matrix by the identity matrix, the matrix doesn't change. It's the exact same as multiplying it by 1. So let's take a look at this example on the identity matrix, and if you want to do this in your calculator, feel free. We'll do it together. So the first example we're going to look at is 4, -2, 5, -9. We're going to multiply that by the identity matrix. So to go to matrices, we're going to hit second and then the inverse button. It's going to take us to this matrix menu that says names, math, and edit on the top. And we're going to go ahead and go into matrix A. So we'll scroll over to edit and hit enter with that 1 highlighted. Matrix A is a 2 by 2 matrix. So 2, enter, 2, enter. And then you'll see it's got 4 elements that we can put in there. 4, hit enter. And then when you're putting in a -2, make sure that you use the negative sign. -2, hit enter. 5, enter, and -9, enter. Okay? Now at this point, this is already saved in here. We don't have to do anything to save it, so I can go back to the matrix menus, second, inverse. And now I'm going to edit matrix B, which is the identity matrix. So it's a 2 by 2 matrix. And it's 1, enter, 0, enter, 0, enter, 1, enter. And so that's saved now. And I went to my home screen. Whenever you're doing a matrix operation, you want to go back to your home screen here. And we can go to second matrix, matrix A. And we're going to multiply that by matrix B, which we put in as our identity matrix. So you kind of have to remember which matrix is which. You multiply it, and there you go. You get an identity matrix there of 4, -2, 5, -9. The inverse of an integer is just 1 divided by that integer, or a to the -1 power, this indicates inverse, equals 1 over a. If you multiply this number by its inverse, the product is always 1. So if we think about a number like 2, the inverse is 2 is just 1 over 2. 2 times 1 over 2, or 2 times a half, is just going to be equal to 1. Similarly, a matrix also has an inverse. If you multiply a matrix by its inverse, the product is the identity matrix. Instead of multiplying a number by its inverse and getting 1, if you multiply a matrix by its inverse, you get the identity matrix. Note, not all matrices have inverses. So we're going to look and see how to figure out if a matrix actually has an inverse or not. In example 1 here, we want to find the inverse of the following matrix. In example 2, we're going to multiply that matrix above by its inverse. The reason we're going to do this is to check and see if we get the identity matrix. Let's do that together. In the examples below, it says find the inverse of the following matrix. So to find an inverse in the calculator, we'll go back to the matrix menu and we'll edit. I'm just going to work with matrix A again. And it's a 2 by 2 matrix with the elements of -4, 2, enter, 8, enter, and -5, enter. Now I'm going to quit this, and I'm going to go back to the home screen, and we'll pull up matrix A. And then where the matrix menu is, it's kind of handy, that x to the -1, that says to find the inverse. So there's our inverse. Now if you get these as decimals, but you want them as fractions, here's a little tip for you. Go to math, and that first option there under math says turn that answer into a fraction. And so we get the fractions in there, which I prefer to decimals because decimals are sometimes rounded. -5/4, -1/2, -2, and -1. And it says multiply the matrix above by its inverse, okay? So what I'm going to do again is go back to I'm going to go back to matrix, and I'm going to edit matrix B now. And matrix B has the fractions, and to enter a fraction in here, we're going to just do 5 and then divided by 4, and that's how we'll enter a fraction. It changes it to a decimal, but that's perfectly fine. -1/2, -2, and -1. Okay? So now let's go back to our home screen. We'll multiply matrix A multiplied by matrix B, because that was the inverse matrix. And lo and behold, what do you get? You get the inverse matrix. You get the inverse matrix here, 1, 0, or sorry, you get the identity matrix. And I'm going to put in parentheses here. Identity. When we're working on inverse matrices, we want to know about what's called the determinant. The determinant of a matrix is a special number for square matrices that helps determine if a matrix has an inverse. It's also used in calculating the inverse matrix. For a 2x2 matrix, the determinant is calculated by the following equation. So I've got A, B, C, and D in for my elements here, right? Just these variables. So the determinant is just going to be A multiplied by D minus B multiplied by C. It's a little more complicated if we get into 3x3, 4x4, 5x5 matrices, but this one's not too bad to do by hand. If the matrix is bigger than a 2x2, you probably want to do that in your graphing calculator. So we'll grab our graphing calculators and we'll do this example together. Find the determinant and the inverse if it exists. The example here says we want to find the determinant and the inverse if it exists. Now remember, the determinant determines whether or not an inverse is going to exist. So we're going to go to our matrix menu, second inverse, and we'll edit matrix A. It's a 2x2 matrix, and we got -2, 5, -2, and -4. We'll go back to the home screen here. And the reason we want to go to the home screen is when we put this in the calculator, we're actually going to get, this is what we're going to put in the calculator, determinant of matrix A. Now, if you didn't put that in matrix A, if you used a different matrix, that's perfectly fine. So go to the matrix menu and then go over to math, and determinant is the first option there. So hit enter, and it'll pull it up on the home screen. Then we want to grab matrix A, hit enter again for matrix A, close your parentheses, and we get 18. So the determinant is 18. Now we use the determinant to calculate the inverse. So if we get some funny fraction in our inverse, we'll see that a lot of the elements will be divided by 18 or by 9 or something like that. That's because of the determinant. So let's go back to matrix, get matrix A, and we'll take the inverse of it. Now these look crazy, long decimals, but what we can do is go back to math and turn it all into a fraction. We'll get this nice matrix here, and I'm going to put A to the -1 to denote the inverse is -2/9, -5/18, 1/9, and -1/9. Now, for those of you who think, I'd rather learn how to do this by hand in case I ever need to do that on a test or later on in math, you can do that by hand. These notes are on your note-taking guide, but know that I don't expect you to do this by hand because when we start working with bigger matrices, we're just going to put them in the calculator. So we learned that the determinant is AD minus BC. And if we're trying to find the inverse matrix, we want to switch the positions across the diagonals of A and D and B and C, and then B and C also become negative. Finally, if we want to take this whole matrix and say we're going to find the inverse of it, we're going to do the inverse of the determinant, that is 1 divided by AD minus BC, and we're going to multiply it by the matrix D, -C, -B, A, and that will give us our inverse matrix. Well, I really hope this video was helpful to you. Hopefully you learned a little bit more about matrices, determinants, inverses, and the identity matrix and how all those work together. Hopefully you got a nice review of matrix multiplication as well. If you still have questions, leave them in the comments below and I'll be happy to help you out with those. And if this has been helpful to you, don't forget to subscribe. Thanks for watching.